Hi, I'm Chris and I'm an iOS developer at Livefront. Welcome to SQLCipher and the Swift Package Manager. SQLite is a popular option for storing app data on users' devices. SQLCipher is an open source extension to SQLite that adds strong encryption to keep your user data safe. Unfortunately, SQLCipher doesn't yet provide Swift Package Manager support. In this talk, we'll explore how to set up SQLCipher in a Swift package setting. We'll begin by looking at a simple demo app that's storing unencrypted user data on a device. Then we'll grab SQLCipher's source code and drop it into a local package. Next, we'll integrate this into our demo project. And if all goes well, our demo app should look the same on the outside, but be fully encrypted under the hood. When we conclude, you'll have an easy recipe for using SQLCipher in your own project via Swift Package Manager. So let's get started. I've created a simple demo app called Customers for today's talk. The app itself is a thin view layer that displays customer information. The first screen is a list of customers, and the second screen displays a single customer's contact details. All of the business logic lives in a Swift package module called Contacts. For the purpose of the demo, Contacts seeds the database with test users the first time it runs. To keep the Contacts module simple, I've pulled in the open source SQLite.swift library to handle the low-level details of interfacing with SQLite. Right now, the customer data is unencrypted. That means that if someone could acquire the database, they'd have easy access to our customers' private information. So let's bring SQLCipher into our project and start encrypting our users' data. The SQLCipher documentation explains how to build a source amalgamation for an iOS application. So let's begin there. First, we clone the SQLCipher repo, and then we build the source amalgamation, following the steps in the documentation. This is building C source code rather than a binary, as you might be used to. Now we have our generated C and header files, but instead of dragging these into our app as described in the docs, we'll create an SQLCipher package in our demo app and put them there. First, we move the C source file into the sources folder, and then we create an include folder in sources and put the header file there. We'll also copy over the open source license. At this point, there's an extra step for Swift Package Manager. We need to add an umbrella header to the include folder. The SQLCipher documentation specifies some C and Swift flags to set in an Xcode project's build settings. Instead, we'll set these in our SQLCipher package manifest. Since this is a C-based package, we can ignore the Swift flag for now, but we'll need to specify it elsewhere later on. Finally, we need to link the foundation and security frameworks. Now let's figure out how to plug our new SQLCipher package into our project. The Contacts package doesn't touch SQLite directly, since I brought in SQLite.swift to handle that. By the way, there are many options for working with SQLite and Swift, and you may well have your own code for the job. SQLite.swift works well for the purpose of this talk because it already has SQLCipher support via CocoaPods. So we just need to swap out CocoaPods and use Swift Package Manager instead. Regardless of your approach, most of the details we're going through will still apply. If we search for import SQLCipher in SQLite.swift, we find that it uses SQLCipher if an SQLite.swift SQLCipher build setting exists. Unfortunately, Swift Package Manager doesn't allow us to specify build settings on third-party dependencies. To do so, we'll need to download the latest stable release of SQLite.swift and drag it into our demo project. Once we've done that, we'll update the Contacts package to use the local SQLite.swift package. Now that we have a local SQLite.swift package manifest, we can update it as necessary. We first declare a dependency on the local SQLCipher package, and then declare our build settings. Some trial and error revealed that we need the same C settings as in the SQLCipher package. We also need the Swift setting specified in the SQLCipher documentation, as well as the Swift setting that tells SQLite.swift to use SQLCipher. With everything hooked up, it's time to add encryption to our customer's app. Returning to the contacts package, we now have access to SQLite.swift's key method. This method sets an encryption key on the database. Before we run the demo app again, I'll delete the old unencrypted database. It's possible to add encryption to an existing unencrypted database, but we'll leave that for another talk. For the sake of completeness, I'll pull in Valet and store the encryption key in the device keychain, rather than in the source code. When we run the customer's app now, it looks and behaves the same on the outside, but the data it's fetching from the database is fully encrypted. If I try to inspect the contents of the database, I'm unable to read it unless I know the encryption key that's stored in the keychain. In this talk, we've learned how to set up encrypted SQLite with SQLCipher using the Swift Package Manager. At some point, SQLCipher will likely provide their own Swift Package Manager support, but until then, you can always roll your own solution like we've done today. One final note, although we've been working in the context of an Xcode project with our demo app, the local Swift packages work equally well as standalone Swift packages. Thanks so much for watching, and happy encrypting.